can quite understand what's going on here. So let us try to discuss this question again. So there's a factory, they got 200 workers, okay? And among these 200, 160 are female, 40 are male. And we're going to choose a sample of 25. So we get 25% from these 200. And S is the number of female in this sample. So first, what is the distribution of S? So quite clear, in this case, this is like doing the experiment 25 times. And there are only two outcomes, only two possible outcomes, male or female, right? And because the number is so big, so whenever you do, the probability doesn't change for each experiment, okay? So if you look at this, 25 people, okay? And it sounds like, doing the experiment 25 times, and there are only two possibilities, male or female. And each time, each experiment is independent. And the probability of getting male or female doesn't change. So what kind of distribution we are looking for? Binomial distribution, right? Okay. So then, what is the probability of S? Okay. So you got to remember the sample is 25, right? So you choose 25 people, and how many gonna be female? S, right? And what's the probability that you're gonna get a female? 0.8, right? 0.8 to S power, and here it is 0.2 to 25 minus S power. This type of question will absolutely be in the midterm, okay? So you've got to be able to do this. So we are done with the first question, okay? Now the second question is, what's the probability of at least 0.8 female? Okay, so in terms of percentage, so you are taking 25 people, right? You are taking 25 people from this factory, and you want to have the probability, okay? So percentage, it is 80%, right? So what does that mean? You're gonna choose 25 people, right? How many of them gonna be female? How many of them gonna be female? S, right? He said the number of female is S. And here you want to have, okay, at least 80% of them will be female. So what does that mean? That means this is the number of female, right? Divided by 25. That's how many people you get. What about this number? It has to be what? It has to be greater than or equal to 0.8. Right? So you have to turn the question into a formula. So here is the formula, right? So what does that mean? That means S has to be greater than or equal to 20. So what about the second question? What's this question about? It is P, okay? So let us say the percentage is pi, okay? Pi has to be greater than or equal to what? 0.8. And what is pi? Pi is divided by 25. That's the number of female, right? This is the number of female divided by how many people you get. So what is this? This is the percentage of female. Okay, this is the percentage of female. Greater than or equal to 0.8. So what does that mean? That means PS greater than or equal to 20. Okay? Any questions so far? Any questions so far? So you have to, so in terms of the question, in midterm, it won't be straightforward. It will be something like this. I will give you a lot of information, and then you have to try to put that information into this formula, okay? I won't tell you, okay, so for example, here you are looking for probability S, right? But here, does the question tell you S? It doesn't. It tells you a ratio. Okay, this is a proportion. So you have to learn to use this information, okay, and also this information, combine them together. Okay, so basically if you get to this point, it is fine. And if you want to use here, okay, if you want to use binomial distribution, you can do that, right? Okay, so suppose you are dealing with this probability s greater than or equal to 20. What should you have? You should have summation, right? S is equal to 20 up to 25, right? And 25 s, okay, and here 0.8 s, okay, and 0.2 25 minus s, okay, because it is greater than or equal to 20, right? So you have 20 to 25. Questions? Okay, let us get to the second one. At most. What means at most? At most means less than or equal to, okay? At most means less than or equal to. So you are looking for p pi, okay, less than or equal to 0.6. What does that mean? That means you are looking for p s divided by 25 less than or equal to 0.6. So that means p s less than or equal to 15. Okay? Questions? So it is not that difficult, okay? So if you can tell the relationship between the ratio and this s, okay, and that should be fine. Okay, the second one, the last one, we have p, okay, 0.68 less than or equal to pi less than or equal to 0.92. The same thing, right? That means p, okay, 0.68 less than or equal to x divided by 25 less. So what do you get? You get p 17 less than or equal to s less than or equal to 28. Okay? Any questions? Of course, if you want to use the binomial distribution to do the calculation, it's going to be very complicated. So what do? We can use normal distribution to approximate the binomial distribution, right? So if you want to use normal distribution to approximate binomial distribution, what's the mean? What's the variance? So what's the variance mean for this distribution? Because we know it is a binomial distribution, right? So P, the binomial distribution is equal to NP, okay, this is mean, right? NPQ, this is the variance. So in this case, the mean is 25, okay? 25 times 0.8. So the mean is equal to 20, right? And here you have variance 25 times 0.8 times 0.2. So what do you get? You get 4. Of course, in this case, okay, so let us use this as an example, okay? Let us use this one, okay? We need to transform S into standard normal, right? We need to transform this into this. So the lady in black t-shirt there, so how to transform this number into a standard normal distribution? So this is S, so this is 15, right? Corresponding S for 15, okay? So you are looking for, if this is 15, but what about Z? Okay, the corresponding Z. What would be the corresponding Z here? So the lady in black t-shirt, what should be here? 3 more weeks we're going to have another midterm. So study hard. What will be here? Excuse me? minus 20, right? And what about here? What should be the number here? 2, right? Because variance is 4, right? So standard deviation should be 2, okay? So far so good. Any questions? Okay. So we are done with this question. If you have any questions, raise your hand. Questions? Okay. Okay, we already mentioned before, right? So suppose x, the mean is mu x, the variance is sigma x squared, right? What about s? S is sample sum, right? Sample sum going to be n times mu x and n times sigma x squared. Okay? And what about x bar? This is the sample mean. So sample sum, sample mean. What is that? That is mu x and sigma x squared divided by n. But as we know, sometimes we're going to deal with the problem like that. So for example, we have, 200 workers, okay, and 160 are female. So in terms of this, we are talking about proportion. This is what we call sample proportion, okay? When we talk about sample proportion, the same thing. So here, the sample proportion, we have P, okay? The distribution, okay, it is P and PQ, right? So in terms of this sample, okay, this kind of sample, we are talking about proportion. So for example, 80% of the people support KMT or LDP in any case, okay? So we have this kind of example. So we are looking for, say, certain number of people, say 40% of Taiwanese watch CNN, or 40% of the Taiwanese watch TTV news, okay? So this kind of proportion data, okay, the probability distribution is P is the proportion, okay? Say 80%, 40%, whatever. And here that is the variance, okay? And the same thing we are talking about sample sum. If we are talking about sample sum, that is going to be n times P and n times PQ, okay? So the same thing. This is the ordinary kind of, the other kind of data. So we are talking about height, score, income, whatever. So we have mu x and sigma x squared. Then the sample sum going to be n times mu x, n times sigma x squared. And the sample mean will be mu x, and the sample variance will be sigma x squared divided by n. This is for sample mean, okay? And this is a different kind of data. We talk about proportion, population proportion. This is the sum of population proportion. And what about let us use P prime, okay? P prime is the sample mean of the population proportion, okay? Sample mean, sample sum for population proportion, sample mean for population proportion. So the same thing is going to be P, and what about here? If you look at this, here it is divided by n, right? So the same thing, it is P, Q divided by n. Of course, we can prove all these things, but we don't want to bother with that because we already proved this, right, and this. So similarly, it is the same. If it is simple sum, n here, n, okay. If it is sample mean, okay, the same thing with the mean, okay, the same thing with the mean. And what about the variance, okay, divided by n, okay, divided by n, divided by n. Okay. Any more questions? Now we are going to talk about a very important theorem. It's called central limit theorem. Okay, if the distribution even if the distribution of the population is unknown, okay, as long as the sample size is very large, then the distribution of x bar will be so even if the distribution of the population is unknown, but as long as the sample size, okay, size, okay, as long as the sample size is very large, okay, the distribution of the sample sum and sample mean will be close to normal distribution, okay. And usually we don't require a very large number, so n is the sample size greater than or equal to 30, that is enough. So as long as the sample size is close to 30, okay, larger than or equal to 30, then we say, in that case, the distribution of sample sum and sample mean will be normal distribution. And this is something very important for us. Now we are going to look at one example here. So question? Okay, we're going to get to a second example here. So let us say x is a uniform distribution, okay? So x is a uniform distribution, so we have x, px, here is 1, 2, 3, and the probability is 1/3, 1/3, and 1/3, okay? So if you look at this, okay, you can see the distribution is like this. So here you have x, right? 1, 2, 3, 1, 2, 3. And here it is 1/3. So you have distribution like this. And this is what we call uniform distribution, right? Uniform distribution. And now let us say we randomly, okay, randomly choose 2 from this population, from this distribution. Okay, can I erase this part now? Okay. So now let us say we choose 2 from this sample. By the way, it is drawing with replacement, okay? Drawing with replacement. So we take one out, we put it back, okay? Take one out, put it back. So how many possible outcomes do we have? How many possible outcomes do we have? We should have 9, right? Okay? So we talked about that before. The number of outcomes will be, here is the population size to the sample size power, right? So you have the population 3 and the sample is 2, right? So what you get? You get 9 possible outcomes, okay? So here we are looking at sample sum, okay? Sample sum or sample mean. Sample sum or sample mean, right? Of course, first you need to know, how many possibilities and what are they, okay? So you can choose 1, 1, right? 1, 2, 1, 3, okay? And then 2, 1, 2, 2, 2, 3. And then 3, 1, 3, 2, 3, 3. Okay, questions? So what is the simple sum here? The simple sum is equal to 2, 3, 4. 3, 4, 5. 4, 5, 6. Okay? What about simple mean? 1, 1.5, 2, 1.5, 2, 2.5, 2, 2.5, and 3. Okay, so what is the probability you're going to get 1? So now we have simple sum, okay, is going to be through 2. Let me put it this way, okay, so we have simple sum and simple mean, right? What's the possible value for S? 2, 3, 4, 5, 6, right? What about X bar? 1, 1.5, 2, 2.5, and 3, okay? Questions? Okay, then we are talking about probability. Probability of S or probability of X bar. Basically, this is the same thing, right? So if S is equal to 2, then X bar is equal to 1. So P of 2, okay, S equal to 2 must be equal to Px bar equal to 1. Okay, can anyone tell me what should be this number? Okay, the lady in gray shirt. What should be here? What's the probability? One-ninth, right? 1/9. What about here? Again, what about here? 1.5. You got 1 and you got another one, right? 2/9. What about here? 3/9, right? And then again, 5, 5, 2, 9, 1, 9. Okay. So as you can tell, what is the distribution here? This is for the population, right? This is the distribution for the population. And what about here? This is the distribution for the simple sum, simple mean. Okay? When we draw the probability distribution of the population is like this. But now what happened? Okay, you look at this. So here you have X bar. Okay, here we use X bar. So you have 1, 1.5, 2, 2.5, and 3. So you have here 1/9, 2/9, and 3/9. So you have here, here, and here. Okay, so as you can tell, this is the uniform distribution, and this is for the population. What about simple mean? It's like this, right? So if you take out more samples, so say n is greater than 2, okay, so let us say n is equal to 3. So let us say n equal to 3, 4, 5, 6, etc. So if you have sample size equal to 3, okay, if you have sample size equal to 3, what does that mean? There are a total of 27 possibilities, right? 27 possibilities. And then you can draw an even smoother picture, right? So you remember what does a normal distribution look like? It looks like this, right? So let us say if you have more samples, here you have 27, here you have 81, here you have 243. As the number of sample increases, okay, as the number of sample increases, it will getting closer and closer to a normal distribution. Because here, the distance, so here is 1, 2, 3, right? Now it is 1, 1.5, okay? If you have 3, it's going to get smaller, 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 so that it will go to the standard normal distribution. So here, this is one of the examples shows you that, okay? Indeed, the central limit theorem is working, okay? If you get more sample, then you can get a distribution. Originally, it is uniform, right? It looks like this. But what about a sample mean? Looks like normal distribution. Okay, any questions? Let us look at one example here. Can I erase this? Okay. Okay, so we have a distribution, okay? It is X, and the mean is 162, and the variance is 16. So we're going to choose 16, okay? A sample size of 16 out of here. And what's the probability that the mean of these 16 going to fall into 160 and 164? So now we just talk about central limit theorem, right? We just talk about it. We say it doesn't matter what kind of distribution the population is. As long as the sample size is large enough, it is greater than or equal to 16, then, greater than or equal to 30, then what can you do? You can use, okay, you can use normal distribution to look for this, okay? So what about here? Do you know, okay, does the question tell you what kind of distribution the population is? What kind of distribution is here? It doesn't tell us anything, right? Because there is no notation here. Suppose n, of course, is normal distribution, but it doesn't tell anything. Okay, it doesn't tell us anything. So in this case, if you want to know the probability between 160 and 164, how to do it? So the next lady there, Ken. Okay, the next one. So, what kind of rule you should use? Can you use normal distribution? Can you use normal distribution? Can you? Can or cannot? Can you use normal distribution to find the probability? Yes or no? Yes or no? Yes. Wrong. Because if you want to use central limit theorem, the sample size has to be greater than or equal to 30. How many here? You only have 16. So it's less than 30. So you cannot use normal distribution. But suppose the question say X is a normal distribution and it is 162, 15. If X is a normal distribution, then you can. Okay, if X is a normal distribution, then for this question, you can use normal distribution. But is it normal? You don't know, right? So you cannot. But suppose the sample size is greater than or equal to 30. Can you use normal distribution? Yes. Okay? So in this case, because the question does not tell us whether it is a normal distribution or not, what should you do? So the next girl there in blue shirt. So in this case, how to get the probability? Still, you can say something here. Okay, even though it is not normal distribution, even though the the sample size is less than 30, still you can say something here. What is the rule to find out the probability here? It is called Chebyshev inequality, right? Chebyshev inequality. So you have Px greater than or equal to 160, less than or equal to 164. Okay? Then you need to get to this formula, right? So what is, it's going to be x minus 162, right? Remember what is the Chebyshev inequality? Probability of x minus mu x less than or equal to k sigma x greater than or equal to k 1 over k squared, right? So then you have to get to this form. Okay, you have to get to this form. So you have x minus 162. Okay, we haven't got that yet. Here you have 2, negative 2. Okay. Okay. So you have x minus 162 less than or equal to 2, right? What is the sigma x? Sigma x is equal to 4, right? Sigma x is equal to 4. And here what do you have? You have 2. So what does that mean? That means it's equal to 0.5 times 4. Okay? So now, again, the question is, can we use Chebyshev inequality in this case? Can we use Chebyshev inequality in this case? The lady next to the girl with dark blue shirt. So can we use Chebyshev inequality in this case? Yes or no? Yes. Unfortunately, the answer is no. Because when you use Chebyshev inequality, k has to be larger than 1. K has to be larger than 1. Why? Suppose it's like this, greater than or equal to 1 over 0.5 square, right? What do you get? This is a negative number, right? This is a negative number. So you cannot use Chebyshev inequality. Okay, so sometimes a lot of examples, okay, 2 more exercises, you can see, what you can use, what you can't, okay? So then the only way to deal with it is trying to use central limit theorem, okay? But then you have to have some assumptions. So let us assume, okay, let us assume x is a normal distribution, okay? If the population is normal distribution, okay? If the population is a normal distribution, then any sample. Doesn't matter the sample size. Okay, the sample size doesn't matter. As long as it is normal distribution, the sample will be normal distribution. Okay, so now let us assume it is a normal distribution now. And here it is what we are looking for. Okay, so then what would be the next step? Okay, the next step is turn this into Z, right? Okay, so the next one, can you tell me how to transform 160 into Z? Excuse me? Right, that's the formula, but what about here? How to turn this one into corresponding Z? Minus 162, right? And what about here? 4, okay? And here you have 164 minus 162 divided by 4. So you have here P 0.5, negative, right? Negative 0.5 less than equal to Z, less than 0.5. Okay. Question. So even though if you look at this, the question sounds like very simple, right? But actually it is not. Okay, you have to have all the ideas, central limit theorem in mind. Okay, if this is not normal, then actually you cannot do anything. Okay, because in this case, can you use Chebyshev? No. Okay. So this is a very good example telling you that when you do the question, you got to be very careful. But suppose if this is greater than 30, okay, then you can do it. Okay, but is this right? Is this right? Is this what the question asks you? It said the mean, okay, the mean of all these 16 samples, okay? Here what you have? X. What you have, it is X. So what you need to do? Actually, this is not what you are looking at. You are looking at X bar, right? It is the mean of these 16 samples, right? Okay? So I'm trying to tell you, when you look at your midterm, you got to be very careful. Actually, this question asks you the mean, okay? The mean of these 16 samples. So is it X? No, it's not X. It is X bar. Okay? Okay. So then P, okay, that's then equal to X. Of course, we're going to transform this into Z, right? Okay, this is going to be Z. Okay. Okay. Now remember, this is no longer X. What is it? It is X bar. Okay? So what should be the mean? What should be the variance? So we know X, the mean is 162, and the variance is 16. Okay, and what about X bar? What is the mean here? So the last one, Yang Tingwei, what should be the mean here? Think about it. Okay. 162, right? Okay, 162. What about variance? 1, okay? The reason? We just say if X, the mean is mu X, variance sigma X squared. What about X bar? The mean is mu X, the variance sigma X squared divided by N. Okay? So here you have sample size 16. 16 divided by 16, what you get? 1. Okay? Okay, the same thing here. Okay, Mr. Wu, what's here? $160 minus 162, 1. Okay, 164 minus 162, 1. Minus 2 less than or equal to z, less than or equal to 2. So as you can see, right, every word is important, okay? Every word is important. So it is not x, it is about what? X bar, okay? So sometimes I may say put the sum, okay? The sum of these 16, okay? The sum of these 16 falls between 160 and 164. What's the probability, okay? So now let us try sum. Okay, this is mean, right? Let us try sum. The sum of these 16 samples fall into 160 and 164. What's the probability? So now, what should be here? It should be S, right? Should be S. Okay. Can I erase here now? Okay, I want to erase it. Okay, the same thing, right? You have x, okay, mu x, sigma x squared. What about s? It will be n times mu x, right? And then n times sigma x squared. Okay? Okay. So then, can anyone tell me what should be the number here? 16 times 162. Got a calculator? 16 times 1 times 162. How much? 2592. Okay? And what about here? 256, right? Okay. So the same thing we can do this problem, right? So it's going to be P, the same thing. And then less than or equal to Z, less than or equal to here. Okay, who's turn? The lady in pink coat. So what should be here? Excuse me? 162? Where you get 162? Where do you get 162 here? Here is 160, 164. Okay, the gentleman there. 160 minus 2592, right? Divided by 256? 16, right? And here you have 164 minus 2592 divided by 16, okay? So can anyone tell me what should be the number here? The whole value. The whole value. 160 minus 2592 divided by 16. How much is that? Minus 152. Okay, so P minus 152 less than or equal to Z, less than or equal to 151. Are you sure? Okay, 151 point. So that will be 0.8. Okay? Okay. Suppose this is what you get. Okay, suppose this is what you get. what is the probability? So the gentleman there in red t-shirt, if this is what you get, what's the probability? Excuse me? Beg your pardon. If this is what you get, okay, z between negative 152 and negative 151.8, what should be the probability? So you need to look at the table. If you remember the table, when t z less than equal to 0, 0 less than equal to z less than equal to 3, what do you get? You get 0.499. And how much is here? Negative 152. Okay? So as you can see, the tail gonna be something like this. Closer and closer to 0, right? So what you get if you get this? What should be the probability? The probability is equal to 0. Because up to this point it is almost nothing, right? Because if it is p z greater than or equal to 3, what's the probability? 0.001, right? Already very small. What about this? 100 something, right? That's even further down, okay? Even further down here. So what you get? 0. The probability is equal to 0. Okay, let's take a break. Let's continue the example here. So remember when we say we try to get this problem, okay, when we have mean and we say we try to find out the probability, because it doesn't tell us whether it is a normal distribution or not, right? Okay, it doesn't tell us whether that's a normal distribution or not. Okay, when we say that, okay, we say, 160 less than x less than 164, right? Okay, but when we do this, there's a mistake here because we haven't paid attention to what? The mean, right? The mean. So actually, what should this be? It should be x bar. Okay, so let us try to find out the probability using Chebyshev inequality again. Okay, so here we already know the x bar distribution should be 162, the mean, and the variance should be equal to 1, right? So we have p, okay, x bar. So then here, in this case, it is x bar minus mu x bar, right? Okay, x bar minus mu x. Suppose it is x, so it minus mu x. But here it is what? X bar, so minus mu x bar, okay? So you have right? Because it is 162, right? 162. So 164 minus 162, what do you get? You get 2 here. So this is equal to 164 minus 162. Okay, and this is 160 minus 162, right? So then you have p, okay, x bar minus mu x bar less than or equal to 2, right? And what is 2? 2 is actually 2 times 1, right? And 1 is equal to sigma x. So this is going to be greater than or equal to 1 minus 1 over 2 squared, right? So that is 0.75. Okay? But, in this case, we also show you that if you're going to use Chebyshev inequality, k, okay, k must be greater than 1. If it is equal to 1, can you do it? No, because when it is equal to 1, here it is 1, right? What you get? 0. You get nothing. So k must be greater than 1. Okay, so now let us get to another example, okay, and we're going to conclude this chapter and get to estimation. So test a dice if you get 1, 2, it is a success. Otherwise, a failure. Okay? And now you cast a dice 54 times. S is the number of success. The first question, find this. The second question, okay. Can I erase this here? Okay. Okay, so we have, you are looking for probability of S greater than equal to 10, less than equal to 20. And the second question is the probability of the ratio of success less than 4/9. Okay, less than 4/9. Okay, so whose turn? That gentleman's turn in white t-shirt. How to get his answer? What's it? What should that be? What kind of distribution? What kind of distribution is S? What kind of distribution? This line. What should be here? You are looking at a camera. Okay, Miss Dunn. What should be here? Your turn again. It is a binomial distribution, right? It is a binomial distribution. Summation, right? Get you started. Summation, and then summation S is equal to 10 from 10 to 20, right? Okay. What should be the number here? Next one. What should be the number here? Pardon me? Excuse me? Are you sure? How many experiments have been done? How many times? 54 times, right? You have done this experiment 54 times. How many of it is success? S, right? Okay, what's the probability of success? 1/3, right? S power, and then how much here? 2/3, right? 54 minus S. Okay? You know, this kind of question definitely will be there. If you cannot answer it, I will see you next year, right? Okay. What about here? You know, the lady behind the girl with gray shirt. Okay, what should be here? Second question. You know, you tell me how to put it in terms of formula, okay? If I'm going to put down a formula, right? What should this be? In terms of formula, what should that be? Okay, the girl in gray coat. What should be here? You try to pretend you are not listening, right? The next one, the girl in pink coat. What should be here? Louder. S less than or equal to 4/9. Are you sure? S is the number of success. It must be 0, 1, 2, 3, etc. Right? Can it be less than 9/4? If S is less than 4/9, if S is less than 4/9, there is only one possibility, is equal to 0. Are you sure that's the way the question asks you? Is it the probability of the ratio of success? Because how many times have you tried? You try 54 times. And here you are talking about among these 54 times, the ratio of the success less than 4/9. So it is not this. S is the number of success. It's not the ratio. Right? So next one. What should it be here? Excuse me? Right, so basically that's S divided by 54, right? This is the ratio of success, okay? Less than or equal to 4/9. And so that is, okay, probability S less than or equal to 24, okay? So, you know, when you work on the problem, first thing you have to do is trying to translate all the words into formula. If you fail this part, you are doomed, okay? See you next year. Okay, questions? Okay, so basically, if you're going to follow normal distribution, can you do it? So if you're going to use normal distribution, right, what's the mean? Actually, this is a binomial distribution, right? So what's the mean? This is a binomial distribution. What's the mean? What is the mean? The next one. What is the mean here? $18, right? I heard someone say 18. And what about the variance? How to get 18? 54 times 1/3, right? What about variance? variance. It should be times 2/3, right? So what do you get? 12. Okay? You know, it really worries me. You still got confused with all these simple formulas. You will be in trouble in the midterm, okay? Working hard, study hard. Okay, questions? Any questions? Okay, we'll finish this chapter. We will get to estimation, okay? The next chapter, estimation. Okay, questions? Can I erase this here? Okay. Okay, so when we say estimation, actually you need to have a good tool. So we say you need to have a good estimator. Okay? When you get a good estimator, and then you can find a value using this estimator, and you get the value that's estimated. Okay? So basically, you know, if you want to have a good estimator, it has to be unbiased. Okay, unbiased. What means unbiased? So suppose this is theta hat. This is an estimator, okay? And the true value is theta. So if you're going to have an unbiased estimator, then it has to be expectation of theta hat is equal to theta, okay? So in this case, if you can have an estimator that for the expectation to get to the true value. So this is what we call unbiased estimator. And suppose expectation of theta hat greater than theta or less than theta. This is what we call positively biased. Positively biased. And this is what we call negatively biased. Okay? Positively biased, negatively biased. And then we talk about the second issue. The second issue is that, okay, you need to have an efficient estimator. Okay, so if variance of theta I, okay, less than variance of theta hat j. If this is the case, okay, if this is the case, that means theta hat I is a better estimator than theta hat j, okay, because here the probability you're going to get it right will be much higher than this one, okay. So generally you prefer to have one is close to the true value, okay, here, and that is more efficient, so that means the variance is smaller. Okay, so basically that is what is all about here. Okay, questions? Okay, then I'm going to erase it, and we're going to try several things here. Okay, we're going to try several things here. So let us say we have x bar, right, is equal to summation 1 over n xi, okay? So this is a estimator, okay? It is what we call x bar, okay, x bar, and then it is 1 over n summation xi, okay? Of course you get expectation of x bar, okay? What is that? That is equal to expectation 1 over n summation xi, right? What you get? 1 over n, okay, expectation x1, expectation x2, at a several expectation xn. Okay, what do you get? You get 1 over n mu x, mu x, mu x. How many? You have a total number of n. So what you get? Mu x. So expectation of x bar is equal to 1 over n summation xi. It is equal to mu x. So what does that mean? X bar is an unbiased estimator for mu x, right? So x bar is an unbiased estimator for mu x. Okay? Because expectation of x bar is equal to mu x. Okay? What about this one? So let us say x hat. Okay, x hat, it is equal to 1 over 3. Okay? x1, x2, x3. Can anyone tell me, is x hat, okay, this is read as hat, okay, x hat. Is x hat an unbiased estimator for mu x? The same thing. If the question asks you whether an estimator is an unbiased estimator or not, you try to get the expectation. So expectation of x hat, okay, what is this equal to? This equal to expectation 1/3, okay, x1 plus x2 plus x3, right? And so you have 1/3 expectation x1, expectation x2, expectation x3, okay? What you get? You get 1/3 times 3 mu x. So it is also mu x, right? So in this case, this one is also an unbiased estimator for mu x, right? So now the question is, this one, okay, is an unbiased estimator for mu x. This one is also an unbiased estimator for mu x. Which one is better? Okay, which one is better? When you ask which one is better, you're going to ask efficiency, right? So which one has a smaller variance? Okay, which one has a smaller variance? So we have x bar, okay? The mean is equal to mu x, right? What about the variance? The variance is sigma x squared divided by n, right? What about x hat? Okay, what is x hat? The person before Yang Jingwei. Okay, so what should be here? We are talking about x hat. What should be here? It should be clear to you, right? Expectation of x hat, what is that equal to? Mu x, right? What about variance? Variance. What about variance? Okay, let us try. Okay, let us try. So you are going to try to find out variance x hat, right? This is what you try to find out, right? So that is equal to variance 1/3 x1, x2, x3. If you're going to move this out, okay, what should be the number here? 1/3. You're going to move 1/3 out. What do you get? What's the number? 1/9, right? Okay. And V x1, x2, x3. And supposedly we say, these kind of experiments are all independent, right? So what you get? You get 1/9 times 3 sigma x squared. So it is 1/3 sigma x squared, right? Okay, now the question, dear you, okay? Which one is more efficient? You have two, right? Which one is more efficient? Which one? Okay, Yang Tingwei. Which one is more efficient? The top one or the bottom one? This one or this one? You have to choose one, right? Which one? Actually, there's a condition. If n is equal to 1, which one is better? If n is equal to 1, which one is better? This one is better, right? When n is equal to 2, which one is better? Still this one. When n is equal to 3, both are the same. When n is equal to 4, this one is better. When n is greater than or equal to 4, x bar is better. When n is less than 4, that means n is 3, 2, 1. This one is better. Okay? So sometimes there is a range. Okay? Okay, questions? Okay, we're going to try to prove another one. Okay? The question is why this one is equal to this one. Expectation of x squared is equal to sigma x squared. This is what we want to prove. Okay? Remember, this is equal to expectation 1 over n minus 1, right? Summation, okay, xi squared minus, okay, n x bar squared. Right? Is that right? Questions? So this is the formula, right? Or you can say, it is 1 over n minus 1 summation xi minus x bar squared, right? The same thing, because after you simplify it, this is what you get. Okay? Questions? This is what we talked about at the beginning of this semester, right? This one can be simplified to this one. Okay? I don't want to do this again. You should be able to do it. Okay? Now, we can move this out, right? 1 over n minus 1. Okay? And expectation, summation, xi squared minus n x bar squared. Questions? We just move this out, right? Okay? And then, here you have 1 over n minus 1 expectation. Because you have x1 squared, x2 squared, right? So you have here x1 squared plus expectation x2 squared, etc. plus xn squared. And minus n x bar squared. Okay, any question to this point? We just expand this equation, okay? For this form, okay, because you have x1 squared, x2 squared, etc. So you have here expectation x1 squared, expectation x2 squared, etc. Right? And you have expectation n x bar squared. So move n out, right? Expectation x bar squared. Okay? Let me erase this part here. Okay. Questions? Okay, can anyone tell me what is this equal to? Suppose you have expectation x squared. What is that equal to? Yang Qingwei, is that your turn? Your turn. Okay. What is expectation x squared equal to? It is equal to what, Mr. Wu? What is this equal to? Right. So it is Vx plus mu x squared, right? That is expectation x. Okay, but it is squared. Okay. So then what you get? What about this? Expectation x bar squared. Okay, so this is going to be sigma x squared plus mu x squared, right? What about here? The next one. The gentleman in red t-shirt. What is this equal to? The gentleman in white t-shirt. It should be simple, right? Because this expectation x squared is equal to Vx plus V mu x squared, right? This is expectation x bar squared, right? So then what you get? You have Vx bar, right? Plus mu x bar squared. Okay, can anyone tell me, the gentleman in red t-shirt, what is Vx bar? What is Vx bar? I beg your pardon? Vx bar, what is it? Sigma x squared. Can you speak louder? That's the same thing as this one. I need you to tell me what that, you have to further simplify it. If you tell me sigma x bar squared, that is the same thing as this one, right? Okay, suppose you have x, mu x, sigma x squared. What about x bar? What is that? And then? Right. So it should be mu x and sigma x squared divided by n, right? So what is this? This is actually sigma x squared divided by n, okay? And mu x bar is equal to mu x, so mu x squared. Okay, questions? And then you have 1 over n minus 1. Okay, here, the first one is mu x squared plus sigma x squared, right? The second one, the same thing, mu x squared plus sigma x squared, etc. Mu x squared plus sigma x squared. Okay, and what about here? Minus n, okay, what is x bar, expectation x bar squared? It is equal to sigma x squared over n plus mu x squared. right? Okay. So now, this is 1 over n minus 1. How many do you have? 1, 2, up to n. So you have n times mu x squared. How many sigma x squared? 1, 2, up to n. So plus n times sigma x squared, right? Here, n times n, sigma squared over n, so you get sigma x squared, right? N times mu x squared minus n times mu x squared. Okay? So what you get? Here, you have n mu x squared. Here, you have n mu x squared. Here, you have n, you have minus 1, so you have 1 over n minus 1, n minus 1, sigma x squared. So what you get? Sigma x squared. Okay? So the reason we use, for the population, we say it is 1 over n times summation xi minus mu x squared. For simple variance, it is 1 over n minus 1 summation xi squared minus nx bar squared. Why? Why do we use 1 over n minus 1? It is because it will be an unbiased estimator. Okay? This is the reason we use 1 over n minus 1. Okay? Questions? Okay, then we're going to get to one more example here. Let us take a 5-minute break. Okay, let us take a break, 5 minutes.
对，因为他不敢面对镜头，然后第二个是他就是会吃螺丝，吃的很厉害啊。他开始他就会讲个几分钟就开始对镜头会松墙。
那像他自己老师在外面也在里面摄影，外面是
对。
那比如说老师比较重入，他需要机器人需要去做这个重入设计关系。
重入的话，那个地方我们这个地方就要开始停止，就要做停止动作。那不用倒带，因为到时候我们就要后制作，所以再剪，那就是停止，赶快停止，然后就是看老师
这边也要
对，要停，然后看老师要做什么。
所以那边体面就是老师
没有，我这边我们进去不要弄。那老师如果时间久的话，我就赶快把那个带子放两边来。或者说你们如果有那个带子的话，就赶快放大。因为老师请你就是做一些研究，就是看什么东西要补啊，或什么之类的，弄。对啊，因为老师的时间很短，老师不可能来。你今天录坏了或者怎么，老师他就走了，就不高兴。所以有时候老师的心情的话，你看比较紧。对啊。老师脾气不好，老师都没开。这样子，
他们平常讲课，大家都会学分享，我们也对着机器讲。
对啊，他们会很不习惯，而且会常吃螺丝，有时候还不知所云。那你有时候对啊，还要当个安抚那个，请老师就是要不要太紧张了。
所以，那种带子大概
它可以90分钟。对，如果说比较长，如果比较好的画质的话，60分钟。那画质比较好，60分钟。 因为那个在里面嘛，外面不知道。它里面老师的话，停止再按一次就停止，然后
不要重来。对，录到刚开始都录得很顺，他就是因为 PPT。
对，也会这样子。
我鬼让他点来，
那也是有可能的。但是就是说，我们如果常去注意，赶快倒单，或者是说赶快优先的换单，它就不会有问题。对。你是看我们哪，就是说你估计一下，就是说时间多少，只是要去掌控一下时间。还有就是你会放一个时间表在里面，像录多久，然后提示一下。比如说他的课程起来，课程1小时，40分钟，不然他讲到一个其实有的老师他讲他如果讲得很顺的时候，也有过头的那种情形，就是一直讲到90分钟，还是60分钟，又一直讲那90分钟。可是对一个学生来讲的话，他没办法接受这么90分钟那么长的，可能他会觉得说，所以在课程安排老师讲英文的方面，就是尽量就跟他讲，你要讲多，你要讲几分钟，你就是说，这样一个课下来，一个学生能清醒的程度的话，这课应该
就是去很长，然后你自己再去把它分上去。
对，
切割。
只是分章节，因为跟老师有相关的，因为至少有章节。3堂课分啊，对啊，怎么知道他在哪？
他先跟我们讲，
对啊，所以
不用看大纲啊，然后或是做什么事情，
大纲我不因为有的老师讲，有的老师讲他讲
听不出来，
他到底
切的，
对啊，到底他切的点是哪？
所以他一开始就说好，那现在我们进入另外一个，
对啊，所以这些项目班的资料呢，还有讲的东西都是找这个老师，所以老师自己要知道。知道了，那其实我们都是做提